right? So what are we going to talk about in this particular lecture is, first, what are the things that led to Titanic disaster? Sorry, somebody was asking to. And then why are the windows of aircraft in the shape they are in now? And finally, the present COVID situation, where we know in a lot of places thermal scanners are used to test our temperature to find out if probably we are a possible case of corona infection. So there is a replacement for that also. And you will see there's physics involved in almost everything. So let us start with Titanic. It's a little more interesting. Okay. So now Titanic, when it was first built, it was labeled to be the ship that cannot be sunk at all. And they said this particular ship is one of the best, and according to our builders, even in the worst possible situation, it is like the two ships colliding, it is not going to sink. Why did they say that? What really happened, we'll see as and when it goes. So the Titanic was quite long, 882.75 feet, and the tonnage was 46,000 and odd. It had 7 decks. 7 decks means it's like 7 floors. It had 7 decks, and the estimated speed was 23 to 24 knots. That is the maximum speed that was possible. The current day ships can reach up to a maximum of 30 knots, but Titanic was able to go up to 23 to 24 knots. Okay. Now timeline. So 10th April was the time when Titanic started its sail. It was from England to the US, and it set sail on 10th April. 14th April, 11:40 p.m., Titanic got a warning that there was an iceberg ahead. So there was some human error also involved, is what I heard. The radio operator of Titanic was getting plenty of messages earlier about the iceberg, but I believe he was actually sending messages from first class passengers to their near and dear ones that they were traveling by Titanic, and he chose to ignore these messages. At one point, he even told, I believe, these people, please shut up. So by the time he received the message, it was actually 11:40 p.m. and the iceberg was just ahead. So by the time they could realize, they went and rammed into the iceberg. 11:50 p.m., within 10 minutes of getting the warning, water had poured in and risen 14 feet in the front part of the ship. And by 2:20 p.m., the Titanic was broken. When I say broken, most of the passengers were sinking, or most of them froze to death. Why they froze to death, that also we'll see. And 15th April, 4:10 p.m., that is from midnight to morning, around 4 hours, the first lifeboat came to pick up the survivors. So which means had the people in the Titanic been able to hold on for 4 hours, all of them would have been saved. There was a major error, of course. There were not many lifeboats, and they thought lifeboats are a waste, and they didn't take in many lifeboats. That was one thing. And in each lifeboat, you could accommodate quite a bit of people, but only the few first class people were accommodated. That's why very few could be saved from Titanic. So now let's just see what led to it. So before the Titanic met with this disaster, there was a trial braking they found. Trial braking was something when you go by your bike or your car, you apply brake and see when it stops. So similarly, a trial braking was done. And this operator, when he got the message that there was an iceberg ahead, he had an estimated 37 seconds to respond to the warning. When I say 37 seconds, from the place where the Titanic was to where it would go and ram into the iceberg, they had only 37 seconds. So they had 37 seconds to think what to do, to maneuver with Titanic and save a disaster. So the distance remaining was only 900 feet. 900 feet is very less for a ship. The bottom image you see is the Titanic, which was recovered later on. And it was traveling at a speed of, the velocity of 22 knots. 22 knots is very near to its maximum speed of 24 knots. So now what happens is, it was traveling very fast. The iceberg was also looming ahead. So now let us see what could have averted. Now deceleration required. Titanic was traveling at a velocity of 10.8 meter per second. That is, I have converted the knots into a meter per second. And the time remaining was 195 seconds. So which means, acceleration is rate of change of velocity. So deceleration is also rate of change of velocity in the negative sense. So which means Titanic required a deceleration of 10.8 by 195 seconds, which is 0.055 meter per second, which 6 seconds squared was never achieved. Then what happened was, we'll see more of the other three later on. What happened was, the material with which the Titanic was built was not good enough, and it did not undergo the kind of fracture or the kind of dent it should have actually happened. So there was Titanic was supposed to be an engineering disaster because the material fractured easily. That was the second concept. We'll see a little more of these as and when we go. Inertia. Inertia was also involved in the Titanic crash. So we would have studied in your school about inertia. The first law, Newton's law, first law of motion. Every object continues in a state of rest or of uniform motion along a straight line unless acted upon by an external force. Just meaning that any object cannot change its position easily. So Titanic was a huge ship. Now what happens is, when can it actually overcome all this? Number one, it had to be traveling slow. Then it had to be small. It has to have sufficient time. It was not traveling slow. It was traveling extremely fast. So it could actually not change its course. Second thing is, the load has to be lesser. That was also not there because Titanic was traveling to its full capacity. Plus, it did not have the time. So it's not sufficient time to alter this. So Titanic could not overcome this inertia. Buoyancy. So what is buoyancy? So you take something and put it on water, it floats. That's buoyancy. Buoyancy is the upward thrust which is exerted by fluids. So you hold a paper and blow it. What happens? The paper blows on top. That's buoyancy. So buoyancy, the necessary buoyancy was never achieved. We'll see that in detail now. Okay. First, before discussing that, let us see how the Titanic was built. So you see the red lines at the bottom. They are all known as watertight compartments. So every ship, when it is built, will have numerous watertight compartments at the bottom. So even when you go in a boat, you see, you will be sitting in the boat. At the bottom, you'll have an extra space with logs on it. So watertight compartments are built in such a way that it will give buoyancy to the ship. So why does the ship generally float on water? The ship has lesser density than the salt water. So it floats on water. To give an extra buoyancy, you have these watertight compartments which are generally free. And Titanic was built in such a way that, so you see so many watertight compartments here. There were around 16 watertight compartments here. So what was told was, even if water enters inside 3 of the watertight compartments, Titanic will still be able to sail. That did not happen. Water entered inside 5 watertight compartments and even the 6th one. So what happened? The Titanic started to tilt in this way. That was what happened. This is the basic build of Titanic. So now going into the physics involved into this Titanic. Okay, this is another image. This is the original image of Titanic, which was recovered later on. So what this red line shows, this is how Titanic fractured. Or let me put it easily, this is how the Titanic broke. So what happened was, just a minute, somebody is in the meeting. I'll admit. Okay, so what happened was, once this is a crack, putting it in scientific words, once there's a crack that is initiated, that crack should stay where it is for safety purpose. What happened in Titanic was, once the crack was initiated, it did not stay there. What happened was, this crack went on spreading like this. Or putting it in scientific words, you say a crack initiation, and then there was a crack propagation like this. So this is the original image from Titanic. Now let us see. So this is how the Titanic broke. The Titanic actually broke into 2 pieces. So now let us go on. Right. This is the kind of physics that was being involved in the fracture of Titanic. So first is, could it have been stopped? Maybe. If the deceleration had occurred earlier, it could have been stopped. What do I mean by saying earlier? Number one, they did not receive the message earlier. That is one thing. Number two, they wasted 37 precious seconds in deciding what to do. Number three, this is something some of you would have come across, sonar. Sonar is a kind of sensor, sound navigation and ranging. Sonar was not used then. Had sonar been used way back, probably Titanic would have had sufficient warning. But then there is another version also at that point of time. the sea was full of icebergs. I don't know how far that is true, but this iceberg was really, really huge. So this was the first physics concept. Second, material disaster. So this is one word which is being used often. Titanic was an engineering disaster. Some of you would have studied material science, in which you would have studied about fracture. You would have also differentiated between a brittle fracture and ductile fracture. Let me make things simpler for you. Suppose you're driving a car, you lose control, the car goes and rams against a wall. What will happen to your car? The front portion will probably have a dent. Am I right? You're driving a car, you're traveling by a bus, whatever, a bike or whatever. If you go and ram into something, the part of the car or the bike will have a dent. So what is happening there? You are having a ductile fracture there. So initially there is a disfiguration that is going on. So could it be applied to Titanic? Yes, that was what expected to happen in Titanic. It went and rammed into the iceberg. But what happened was, instead of a ductile fracture, or putting in other words, the Titanic vessel should have been actually dented. But what happened? It cracked into two. It began cracking. So what happened? There was no ductile fracture. There was a brittle fracture. What was the reason for this brittle fracture? Number one, Titanic was traveling in the ocean at a temperature of -2 degrees C, sub-zero temperature. So what happened was, there was a material transition. So the ship lost its strength, and from a normal material, it changed into a brittle material. That was number one. So that is why I'm saying it underwent a brittle fracture rather than a ductile fracture. So we have already seen two different concepts. One is the acceleration or the deceleration, the time factor. Next thing is material. The material could not sustain at sub-zero temperature, and a crack was initiated where a dent should have happened. So what happened? A crack initiation. Second thing is, what happened was, this crack which was initiated had, so the material should have been better built so that there would have been only a ductile fracture. The third thing is inertia, as I spoke about earlier. The ship was huge. So what really happened was, when it's tried, the captain did try to turn the ship. See, that's what you do, right? You're riding a bike. Suppose something comes in front of you. What do you try to do? You try to turn the bike and go, right? So that is what Titanic also tried here. It tried to turn. Please note that the steering in Titanic was very much like the power steering you have in cars now. So which means the steering was extremely good. It tried to turn, but the Titanic was so huge. When it tried to turn, what happened was, the side of the Titanic. So we have already seen the side of the Titanic went and rammed into the iceberg rather than the front of the Titanic. So what happened was, this portion of the Titanic went and rammed into the iceberg instead of the front. Had it actually rammed from the front, probably the damage would have been a little better. But since it rammed it grazed, the side actually grazed into the iceberg. So all these portions, they broke, and water started seeping in. And once water started seeping in, what happened was, water started spreading like this. So what happens? This part of the ship becomes heavier compared to this. So there is an inequality in the mass. So what happened? This was not able to balance with this. Now you can imagine a cantilever. So the external bending moment was much, much more. So what happens? Since this mass was more and this was not able to manage, so ultimately this weight started increasing, and what did you see in Titanic? This crack, and ultimately Titanic broke into two. So this is the kind of thing, failures it had. So there was no deceleration, there was a material disaster, and the inertia part was also playing a part. And finally, buoyancy. Buoyancy is what is floating. When you don't know swimming, what do? You take a rubber tube, hold on to it, and try to float in water. What does it give you? It gives you buoyancy. You cannot float on the water because you are denser. So now the entry of water inside the watertight compartments, what did it do? It modified the density. It's not more about a weight alone. It modified the density of the ship. So when something becomes denser than water, it tends to sink rather than float. So which means the necessary buoyancy was never achieved, and Titanic began to sink. Not only that, people also say there was one more physics concept involved. Because of the extremely cold weather, there was an optical illusion, and the iceberg to the naked eye did not appear very far. It actually, actually appeared very far rather than near, and that was another reason for the disaster. So you can see just in one Titanic disaster, which we have always seen as a movie, there was so much of physics involved. I repeat. So first is acceleration. Opposite is deceleration, velocity, rate of change of velocity. Second thing is material disasters. Some of you would have studied. For people who have studied mechanical branches, please go back and look at your TTT diagrams. You will understand what do I mean by this material disaster. Third thing was inertia. The huge ship could not change its position easily because of the inertia. And the final thing is the buoyancy could never be achieved. Plus a footnote, probably this also, optical illusion may have played a part, but there is no proof for that. There's one more person joining. Okay, this was one physics involved in Titanic. Let me go to another example. We have all drawn aeroplanes. Have we ever wondered why the windows of aeroplanes are shaped like this? They could always be square, right? Like we have it at our homes. One probably we may think, yeah, it is for an aesthetic sense. It will look beautiful if it's shaped like that. Yeah, that may be there. But what happens is, I think you are all aware, the insides of an airplane is generally pressurized. When a plane takes off, people who have traveled by air would have experienced you will have a block in the ear, right? So all this is due to change in pressure. So which means the inside of a airplane is generally pressurized. And just to manage this pressure only, your airplane is like a cylinder. That is the shape of the airplane. So what happens is the insides of the airplane is pressurized, and the pressure is going through the airplane body. So what happens is when it passes through, if the window is circular or oval like this, the pressure is distributed evenly. Putting it in engineering terms, let me say the stress will flow smoothly along all these ways. Suppose it is like this, what happens? Let us not speculate. I'll tell you what really happened. Back in 1953, first time they started flying airplanes at a great height. So there was this flight called de Havilland flight, where they started flying at a greater height, and they started pressurizing the cabin inside. And what happened was, within 1 year, they had 3 accidents. There were 43 people who were dead. 3 accidents within a year, 43 fatalities. They didn't understand why their flights were repeatedly crashing. So obviously people began to tell de Havilland flights are hopeless, don't travel by them and all that. And finally they discovered the culprit was window shaped like this. So what happens is, this pressure is exerted more, is concentrated more in the 4 corners. And when the pressure is concentrated more in the 4 corners, what is happening here? There is a breaking, there is a fracture which will go on. And this window will probably even be blown off, and it will lead to an accident. Or now I spoke in terms of physics. Let me now put it in terms of engineering. So what happens when a flight takes off? The insides of the flight is being pressurized. There is an increased pressure inside the flight. When the flight lands, the pressurized situation is being removed. Again, when the flight takes off, the insides are pressurized. Again, when it lands, the pressure is removed. So what is happening? There is a cyclic stress. When the plane is flying, there is an increased stress. When the plane has landed, the stress is being removed. So some of you have studied about this also. Cyclic stress, fatigue. There is a fatigue that is being created in the airplanes. That is why if they have a square window, the corners will crack and the airplane will definitely meet with an accident. So that's what is being given here. On a perfectly rounded cylinder, stress flows smoothly. So what will the stress do? Pressure. It flow easily like this through the material, a flow that is interrupted by introduction of a window. If the window is oval, stress levels are evenly balanced. Else, what happens? If they are not oval, the stress gets concentrated in the corners. This is another factor. This is another thing where I want to speak about physics. Yes, there are a lot more examples. I'll stick to one more example before I wind up this lecture. the present COVID situation. Before I go into what is being shown here, we have all seen how corona testing is being done. It is not actually corona, it's more COVID-19 because it is a coronavirus has been there for quite some time. But COVID-19 is coronavirus disease 19, which came in 2019. Some of you would know this. So they conduct what is known as PCR test widely. And you all know in the middle there was something called as rapid testing, which was to be tried by Tamil Nadu, and finally they said rapid testing is not good. Of course, there are reasons for that. And now what is being undertaken is PCR testing. It is more biology-based testing. And the results of this PCR testing, whether a person is COVID positive or not, will come to the person maybe from a couple of minutes or to a couple of days, depending on how far the infection has gone. So this is a biology-based testing, and we'll think, what do we have to do? We have a lot to do. So Israeli scientists have now developed a method wherein the COVID test results are available within a few minutes. Now, you know, when you go for shopping, when you try to get inside shops, what do? They have thermal scanners to see if you have a temperature. But that is not totally dependable, because thermal scanner again is something related to you engineers and physicists, because what is happening there? There you are using an instrumentation, you are using a sensor, ECE people, you are using a sensor, and there is a conversion from image into reading. So again, there's a lot of physics and a lot of engineering involved when you're using a thermal scanner. But that is not totally dependable, because there are a lot of people who are COVID positive who don't have a temperature. So this particular breath test, which has been advocated by Israeli scientists, it has been put forward for testing. And it says the success rate is quite high, to the range of 90%. It's a very small one, just like your thermal scanner. So what happens is, it contains a chip with densely packed sensors. A chip and a densely packed sensor. They're using physics principles, and any ECE students here, you will be able to associate it with associate yourself with a chip and densely packed sensors. So what does this chip do? It is able to capture the tiny particle. What do you mean? What do I mean by the tiny particle? And your question may be, it will capture anything. So what is so special about COVID? So COVID virus is a nanoparticle or a quantum dot, which has a diameter between 100 nanometer to 140 nanometer. But most of the other viruses are smaller. So when COVID, with the onset of COVID, there was a lot of talk that was happening that COVID virus is a little larger than the others. So what happens? The trapping or whatever is easier than the smaller ones. So COVID virus has a size between 100 nanometer to 140 nanometer. And it also has electrical properties. This was the news to me also. It is a positively charged RNA strand. COVID virus is a positively charged RNA strand. So it has a particular size, and it has some electrical properties. So it is detected using methods, the world of physics and photonics and electrical engineering. So you may have negatively charged sensors. You can also have sensors which are able to filter these out. Suppose you filtering, just imagine things like you want to filter out something, you want to filter out sand. What will you do? You'll probably even take a bit of cloth and filter out sand. Suppose you want to filter final part, you want to filter larger particles, even your hand is not needed. You can filter out in any other method. So your filter size depends on the particle size, and the reaction depends on the field, on its electrical properties. So this handheld device, what does it do? It captures tiny particles from the breath. So you can just breathe into it, including any virus. It can capture the virus. The chip then reads it through spectroscopy, through a terahertz. Terahertz is 10 power 12 hertz. So it takes only about 20 seconds to read this, and maybe a few more seconds to analyze. There are a few mathematical calculations involved, and immediately it tells whether the person is positive or negative. Maximum is this testing kit will take only 1 minute to give back the result, whether the person is positive or negative. So COVID situation, which is more biology based, also had a lot of physics to it. So not necessarily physics. If you are engineers, you need not think about just physics to it. But what you can think about here are the sensors, a chip, Here is the electrical field which you have to consider, and of course the instrument base. So there's a lot of EC people. There are a lot of electrical people, and for the calculations and the conversions, you probably will require computer science people. But for knowing all this, you must know the basic involved, which comes from the basic sciences. We have seen 3 different examples. Now let us just see the various fields where you can use physics. If you're going to be in biotech, you will definitely use computational analysis. So application of molecular physics techniques, quantum mechanics, molecular force fields, they all involve physics. So if you're going to be a civil engineer, so your first semester you would have read about elastical properties of materials. So in the elastical properties, distribution of load, you could ask yourself, why do bridges have triangular supports? These are things you could ask yourself. There's a lot of physics involved in it. If you're a mechanical branch, I've spoken so much about mechanical branches only now. Any material design, material behavior, loss of motion, I'm just speaking about a few, but there are a lot more involved in mechanical branches. If you're a computer science engineer, you all would have heard about self-driven cars by Google now. Waymo. Waymo is a self-driven car by Google. This involves reaction to inertia, then sensors, and a lot of programming. So when you are doing this programming, you should know the basic physics involved to carry on with your programming. Similarly, computer science, you will also be related to this biotech, because when you're using all this molecular physics softwares, who writes the code? It's the computer science students. Actually, I was handling a subject called bioinformatics special elective, where there was a lot of computer science involved in writing the codes with a little of biology. I think biotech students would probably have a subject like that, but there was a lot of computer science code that was involved, and it's very interesting. And any design of hardware would also involve a thorough knowledge of physics, and the recent hardwares are even exploring nanotechnology. So this is where physics and computer science is related. Electronics, yes, electronics, we know the physics of semiconductors, sensors, everything involves physics. And then electrical engineering, it primarily focuses on applying electricity and magnetism principles from physics to make useful devices and materials. So your question would be, so you think a knowledge of physics will make me thorough? What I am trying to tell you is, with the knowledge of physics, your application knowledge will improve a lot. If it's not just physics, again I'm speaking about, your knowledge of physics, chemistry, and mathematics will make you strong in the basics. And once you start experimenting, you'll be able to apply yourself better. I'd like to quote a small example. When COVID infection started, government actually wanted ventilators to be made. Somebody, can you please mute? Government wanted ventilators to be made because they felt that there'll be a shortage of ventilators. One of our own first-year students called Balasubramanian, he designed an automatic handheld ventilator, which was appreciated and taken into account by Dr. Vijay Kumar, who is the state coordinator of Indian Medical Association and is the head of COVID task force. And I'd also, before closing off, I'd also like to appreciate my first-year students for the past 2 years. They have taken into consideration all these material properties, and 2 batches have actually published papers in UGC journals and Scopus journals. So students who are listening to this, please try to do even better. I am sure your staff will be more than willing to help on this. Your labs will also be available, and please try to involve yourself better and give back. I think that should be it from my side. I hope I made myself clear. In case there are any doubts in this and there are any extra questions from you all, you are welcome to ask questions. I enjoy taking questions. So any questions related to any of these concepts,